Welcome to physics class. Today we want to look at fundamental and derived quantities. And at the end of the lesson, students should be able to define fundamental quantities, list several fundamental quantities and their units, define derived quantities, and write out the units of some derived quantities. Fundamental quantities. Fundamental quantities are foundation of other quantities, and they are independent quantities, meaning that they can stand on their own and they are basic quantities. And these fundamental quantities are 7 in numbers. The first one is length, 2 mass, 3 time, 4 electric current, 5 temperature, 6 amount of substance, 7 luminous intensity. And this table shows the 7 fundamental quantities and the fundamental units and also the abbreviation. And what is fundamental units? Fundamental units are units of fundamental quantities or basic quantities. Okay, so the unit of length is meter and the abbreviation is M. Mass is kilogram, kg. Time is second, S. Electric current is in ampere, A. Temperature is in Kelvin, K. Amount of substance is in mole, MOL. Luminous intensity is in candela, CD. Okay, let's check if you have gotten the basic concept. So look at this question number 1 and tell me the answer. Which of the following is not a fundamental SI unit? Meter, ampere, Kelvin, second, radian. Okay, the best answer is what? E, radian, is not a fundamental SI unit. Meter, that's the unit for length. Ampere is the unit for electric current. Kelvin is the unit for temperature. Second is the unit for time. Question number 2. The international agreed system of units for physical measurement are IBFTS, GMS, KGMS, SCMGS, KGCMS. So which one is the best answer? Is the agreed SI unit? Okay. The best answer is C, kg meter second. Kg, the unit for mass, meter, the unit for length, and second, the unit for time. So the best answer here is C. Now, what is derived quantities? When you have 2 or more fundamental quantities, you have what we call known as derived quantities. So derived quantities is the combination of 2 or more fundamental quantities. And these derived quantities, they cannot stand on their own. They depend on fundamental quantities. So when you combine 2 or 3 or more fundamental quantities, you have derived quantities. So derived quantities are independent, meaning that they cannot stand on their own. And the unit of derived quantities is known as derived unit. The unit of derived quantities is known as derived units. So let's take some work example. We all know in our mathematics that area is simply length times breadth. And the SI unit for length is meter, M. Also, breadth is also in meter. Please take note, length, breadth, height, distance, they are all in meter. So our length is meter M times our breadth is also in meter. So meter times meter will give us square meter or meter square. Volume. Volume is length times breadth times height. So the SI unit for length is meter m. Breadth is also meter m. And height is also meter m. So length m times breadth m times height m. So you have m times m times m. So if you multiply this, you have cubic meter or meter cube. Density. Density is given by mass divided by volume. And the SI unit for mass is kg. And the SI unit for volume, we have done that before, is meter cube or cubic meter. So mass kg per volume meter cube will give us this kg per meter cube, or you can put it in this format: kg meter raised to power of -3, kg meter raised to power of -3. Okay, let's do this. Speed. Speed is distance divided by time mathematically, and the unit for distance is meter, and the unit for time is seconds. So it will give us meter per second, or ms raised to power of -1. Velocity. Velocity is displacement divided by time. So as I said before, length, breadth, height, displacement, they are all in meter. So displacement is in meter, then time is a second. So we have meter per second, or meter s raised to power of -1. The next one is acceleration. Acceleration is the time rate of increase in velocity. And acceleration is given by increase in velocity divided by time. And what is the unit for velocity? Velocity is meter per second. So if you have meter per second, you now divide it again by second, it will give you meter per second square. The next is force. Force mathematically is given by mass times acceleration. And we know that the SI unit for mass is kg, and the SI unit for acceleration is meter per second square. We have done that before, as you can see, meter per second square. So if you multiply kg times meter, it will give us kg meter. So if you divide by this second square, you have kg meter per second square. So another unit for force is also known as Newton, in honor of Isaac Newton. Momentum. Momentum is given mathematically by mass times velocity. And the SI unit for mass is kg, and the unit for velocity is meter per second. Meter per second. So mass kg, velocity meter per second. So if you multiply, you have kg times meter, kgm per second, kgm per second. So to give you kg meter per second, or Newton second. That is another unit for momentum. Impulse. Impulse mathematically is given by force times time. And we have shown force before to be kg meter per second square as the unit for force. So if you come back to impulse, which is the product of force times time. So force is kg meter per second square. So if you multiply with the unit for time, which is second, so and you do the mathematics, you will have kg meter per second. Kg meter per second, because this second in this place is going to divide the second square here as the denominator. So you have impulse to be kg meter per second or Newton second. We can see that momentum and impulse, they have the same units. Next is moment. Moment is force times perpendicular distance mathematically. So force is kg meter per second square, and perpendicular distance, so our distance is in meter. So if you do the mathematics, you have kg times m, will give us kg meter square per second square. And we know that force is also in Newton. So perpendicular distance is in meter. So moment can be in kg meter square per second square or Newton meter. Next is energy or work. Mathematically is given by force times distance. And we know that force is kg meter per second square and distance is in meter. So if you do the mathematics, you have kg meter square per second square or in joules. Next is pressure. Pressure mathematically is given by force acting normally per unit area, force divided by area. And force, as we know, is in kg meter per second square. So divided by area, area is in meter square. So if you do that, you do the mathematics, don't forget this is denominator and this is division. So if you do the mathematics, you have this kg per meter per second square. Kg per meter per second square. Power. Power mathematically is given by work done divided by time or energy per unit time. So work done per unit time or energy per unit time. So and we know that work done or energy mathematically is given by force times distance. As you can see, work or energy, force times distance. So power, which is work done or energy divided by time. So if I take any, maybe work done or energy, I know that work done is force times distance divided by time. And we know that force is kg meter per second square times distance, which is in meter. So if you now divide by second, you do the mathematics, you have kg meter square per second square divided by second. Don't forget this is denominator, so you are dividing it with this. So to give us kg meter square per cubic square, per cubic second. So you have kg meter square per cubic second. So let's take this question. Which of the following are the correct SI units of the quantity indicated? Which of the following are the correct SI units of the quantities indicated? Newton, F, force, Newton per meter, torque, watt, power, kg meter per second square, momentum. So let's check which one is correct. Newton is the unit for force. Yes, that's correct. Torque is same thing as saying moment of a couple. which is the product of force and the perpendicular distance. So it should be Newton meter, not Newton per meter square, or not Newton per meter. So tug is in Newton meter, not Newton per meter. So this is not correct. Watt is the unit of power, yes. Momentum is kg per meter, not kg per meter square. So the correct answer is Roman figure 1 and Roman figure 3. So the best answer is D. Question 4. Which of the following quantities has the same unit as the watt? And don't forget that watt is the unit for power. And what is power? Power mathematically is work done divided by time, or energy divided by time. And we know that work done or energy is given mathematically to be force times distance, all divided by time. So if you take the distance at the numerator and the time at the denominator, distance divided by time will give us velocity. So we now have force times velocity. We have the same units as watt. So the answer is D. Okay, let's take this test question. You have 30 seconds to do that. Okay, the answer is what? C, reactance. Test 2. Let's do that. Test second. Okay, the answer is what? A, ampere. Test 3. Which of the following sets are the unit fundamental? Okay, what's the answer? Length, time, and mass. That is what? C. Thank you.